Hello, my name is Demi, and today we're starting to acquaint ourselves with the products of our company in a new format. Previously, I translated video lessons of my colleague Luke Henderson. He made a huge contribution to popularizing our company on the international market. When the pandemic began, Luke was forced to resign and move to Australia. As you know, we release at least one product weekly, which cannot go unnoticed. Let's get started. Today we have in front of us the HMI module, which stands for Human-Machine Interaction. This term refers to a whole discipline that deals with planning, development of methods and tools that provide convenient interaction between humans and computers. In the first image we see a top site. The first thing to note is the contact map. We have 3 cores, 2 of which are already on sale. The contacts of the same interfaces on these cores are different, so during initialization they should be identified according to the map provided. On the right there is the vertically arranged socket with M-bus contact blocks. At the bottom there are paths of contacts, used to load firmware into the microcontroller. On the left there are 2 pairs of programmable user buttons and LEDs. Above them there's an encoder with a built-in button. At the top we see 2 growth ports, black with a GPIO interface and blue with UART. Before us is a bottom side, where all the electronic components of the module are clearly visible. The first thing that catches your eye is the large 500 mAh lithium polymer battery located in the center. To the right of the battery we can see the microcontroller STM32. Simple electronic components of the circuits are located around the microcontroller. On the right side, we can see a cutout for a flat screwdriver that helps to disconnect the module from the assembly. There is also a product label sticker located here. On this side, there are 3 openings designed for non-standard installation options and wire entry. On the left side, there is a plastic disc-shaped handle for the encoder, 2 openings for LED light passage, 2 round tactile plastic buttons, as well as the letters A and B to denote the data pairs. On the top side, there are 2 growth connectors and contact labels for them. Let's take a look at the schematic diagram. We decided to choose this microcontroller model for 3 reasons. Firstly, it has low cost and high quality. Secondly, it requires minimal components. And thirdly, it has I2C interface. We have already loaded a special firmware into it. The communication with the core is done through the I2C interface, with the contact numbers being SCL on the 17th and SDA on the 18th. The module is powered by an LDO converter, has lower power consumption, small voltage drop, low temperature coefficient, small quiescent current, and high accuracy of output voltage. It takes 5 volts input from the core and produces 3.3 volts output with a maximum current of up to 300 mA. We chose this encoder model because of its convenient plastic handle and built-in button. Phase A signal is connected to the 12th contact of the microcontroller, Phase B signal to the 13th, and the built-in button is connected to contact number 11. Buttons A and B are pull-up, contacts 9 and 10 respectively. Both LEDs are red and connected to contact 6 and 7. All control elements are independent and can be programmed by the user. Note the growth ports. They are directly connected to the core via the M-bus, bypassing the STM32. The battery is also directly connected via a dedicated bat line. The core will step up the battery voltage and return it back on the 5-volt line. Great news! We have added access blocks to UI flow prior to product release. Let's familiarize ourselves with them. First block initializes the HMI module with the specified I2C address. Without it, it's impossible to start working with this module. Second block sets the value of the encoder counter, which indicates how many times the encoder has been rotated. Third block is used to turn on or off the selected LED. Fourth block is used to change the I2C address of the module. Fifth block is used to determine the firmware version of the STM32 microcontroller. Sixth block is used to retrieve the value of the encoder counter. Seventh block is used to retrieve the increment value. Eighth block allows you to determine the state of one of the 3 buttons of the module. In this example code, we are initializing the module for further testing of its functionality. Any changes to the parameters will be displayed on the screen. Using the A button on the base device, we can turn both LEDs on and off. Using the B button, we can increase the counter value by 1000, and using the C button, we can reset it. If you haven't worked with UI Flow before, we strongly recommend giving it a try. It's a truly convenient and easy-to-use platform for rapid development. This product is a module designed for connection to the classic cores via the M-bus. This bus not only has a large number of interfaces, but also provides reliable mounting for the entire assembly. Currently, there are 2 classic cores available for sale, which have excellent compatibility with this module. Each of them has its own advantages and some drawbacks, so please refer to the description on our website to determine which one is right for you. The HMI module is commonly used for industrial control, embedded systems, and smart home applications. However, it's worth noting that its applications are not limited to these areas alone. It all depends on the tasks you set and your imagination. Thank you for watching. See you next time. Goodbye.